So the 4 is when it's positive, points up. When it's negative, points down. We should be able to do kind of like what we just did for our cubic functions, but for our quartic functions, okay? So let's do number 1 together. On number 1, where does this factored form tell me that I have zeros? Nice. Okay, so on the grid that they gave me, I'm going to go plot points at those places. So we've got one at 4, -2, 1, and 5. All right. Okay, so none of these appear to have multiplicity at any of the factors, right? These are all understood exponents of 1, right? We don't have any squares or cubes. So nothing weird should be happening at any of these zeros, right? No bounce, no curve. If I were to multiply these terms together, all these x's have understood exponents of 1, right? So x times x times x times x would give me x to the 4th. Okay, so that tells us it should look something like this because I do not have a negative in front, right? Okay, so we know that it points up over here on the right, and we said nothing weird is happening at any of my points, so I should just be able to cross through at every 0. So I cross through here, and here, and here, and here. So it looks something like that. All right, number 2 appears to have the same zeros, right? So we still have zeros at 4, -2, 1, and 5. So let's go ahead and plot those zeros. So we've got 4, -2, 1, and 5. Again, all of these factors do not seem to have any multiplicity with degree 2, degree 3. So they should all be normal. And we've got 4 factors, right? So again, x times x times x times x is x to the 4th. But what's different about this one? It's got a negative in front. And what did we say that does to our graph? Flips it over. So instead of my arrows pointing up, my arrows now point down, and I pass through those points. So it looks something like this, right? Okay. All right, let's do another one. According to number 3, where do we have zeros? Good. All right, so I'm going to go and plot those zeros. So we've got one at 2, -3, and -2. All right, so this one has an exponent of 2, while these have understood exponents of 1 and 1. So I've got x squared times x, which does give me x to the 4th. Anything that should be flipping this graph over? No? Okay. So we know which way our arrows should point. Anything weird going to happen at any of these zeros? Yeah. At 2, you said we're going to have a what happen? A bounce. Right. Okay, so remember, this 2 tells us we have what's called a double root. But this is true for any even exponent. So this would also happen if that was an exponent of 4 or 6, okay? So a double root, but this is true for any even. Like she said, this gives us a bounce on our graph. Okay, so you guys said that we're pointing up because there's no negative in front. Where is this bounce going to occur? At 2, right? Because this factor gave me the 2. All right, so my arrow's pointing up. When I get here, though, instead of crossing through, I'm going to bounce off. And then these are normal, so I should just cross through on these, right? Which makes sense because we did say both ends should be pointing up. Yes, ma'am.
If it's like even even in those parentheses, why on like number 1 do we not have a bounce since it's a 4 in there?
No, the exponent is an even number.
Oh, okay,
Yeah. Okay. All right, for number 4, where does number 4 say that we're going to have zeros?
2.
All right. So let's plot those. So at 2 and at -1. All right, so understood exponent of 3, understood exponent of 1, x to the 3rd times x does give us x to the 4th. And then what do we notice at the front of this equation? There's a negative, right. So what does that mean about our arrows? Arrows should point down, okay. And is anything weird going to happen at either one of these points? Yeah, very good. So that exponent of 3 is a triple root, but remember this is going to be true for anything that's odd above 1, like 3, 5, 7. Okay, so this is, in fact, a triple root, but it works for any exponent that's odd, except 1. Okay. That we have what looks like a curve or a wiggle on the line. So this causes a curve or a wiggle. Okay, and where is that going to occur at? At the 2. Okay, so like you guys said, my arrows are pointing down. When I get close to the x-axis, instead of crossing through like normal, my graph does this little curve to it. And then it starts to go up and back down. All right. So this is our curve or our wiggle right here. So again, this only happens for odd exponents that are not 1, right? Because at 1, we know it's just a normal cross through, like all the other ones. Okay, so there's our refresher. So at 1, it crosses through. If my exponent is 2, what happens? Bounces. And if my exponent is 3? Curves. Okay, all right. So now that we know what we can draw or what we can conclude from looking at a graph, let's take a look at the following questions where they give us the picture and we write down what the roots are. So for number 5, where would you guys say we have roots? Okay. All right, so we got our -4, -2, 1, and 4. Perfect. How would I write those roots as factors? Nice. Okay. All right, then they do ask for this equation. They ask for it in polynomial form. What does that mean we're going to have to do with our factors?
For the factors, wouldn't we make it x?
Yes. Thank you. She said it out loud. I just didn't write it. What do we need to do with our factors? Multiply them together. Right. Okay, so we'll have y equals or f of x equals, whichever you prefer to use, x plus 4 times x minus 2 times, plus 2, x minus 1, and x minus 4. Okay. So like you guys said, we are going to need to multiply it out. So let's start with multiplying those first two parentheses. X times x gives us, right, x times 2 and 4 times x. And 2x and 4x are like terms. They give us 6x. Nice. Okay. And then 4 times 2, 8. Perfect. Okay. Now let's multiply the second two together. So x times x gives us, right, x times -4. And -1 times x, -x. And again, those are like terms, so if I combine them, I'll get, right. Okay, and then lastly, -1 times -4, +4. Nice. Okay, Now I have to multiply these two together, right? So let's start with this first term, x squared. I'm going to multiply it by everything in the second parenthesis. So x squared times x squared. X to the fourth, X squared times negative 5x. Good. X squared times 4. 4x squared. Perfect. Okay. Now I'm going to do the same, but with the 6x. I'm going to multiply the 6x by everything in that other parenthesis. So 6x times x squared. And 6x times negative 5x. Good. And 6x times 4. Yep, 24x. Okay. Now I'm going to use the 8. So 8 times x squared. Right? And 8 times negative 5x. Nice. And then lastly, 8 times 4. Nice. Okay. So we've definitely got some like terms we can combine, right? So for our equation in polynomial form, we should start with the biggest exponent, which is what here? Right, so I'm going to have my x to the fourth. Okay, I've used that. Next, I'd want to put all the terms that have a cube, right? Looks like we've got negative 5x cubed and positive 6x cubed. Okay, so done with the cubes. For our squares, we've got a positive 4x squared, a negative 30x squared, and a positive 8x squared. What's that? Nice. All right, and then we've got our linear terms. Looks like we've got 24x and negative 40x. Right? Which leaves us with our constant of 32. There we go. Okay. All right, flip it over on the back. And let's take a look at number 6. So number 6 is the same idea, but on this one it says you don't have to write it in polynomial form. You can write it in factored form, but it does say it goes through that point. So that's like what we were doing on the assignment we just graded, right? So you guys give number 6 a try, and then we'll share what we come up with. All right, looks like most of us have number 6. Can somebody tell me where the roots are on number 6? Good. Okay, so what were our factors then? Good. All right. So then they want it in factored form, easier for us, but they do say it goes through that point there, which means we're going to have to find what? The a value. Okay, so what did we plug in for y? Right, is equal to a times, we replaced all the x's with, so we got 1 plus 2 times 1 plus 1 times 1 minus 3 times 1 minus 5, right? Okay, so you add and subtract within all the parentheses, and then you multiplied all your parentheses together, and you end up with negative 96 is equal to what? 48a. Very good. Okay, and then what did we do? So a was nice. Which makes sense because if you look at our picture, it does show that the ends are pointing down, right? Okay, so our equation has that negative 2 in front, followed by the factors x plus 2, x plus 1, x minus 3, and x minus 5. Okay, let's take a look at number 7. On number 7, where does it look like we have roots?
-3, 2, and 4.
Okay. Anything weird happen at any of those roots? A bounce. Where at?
At 2.
2. Okay, so if we have a bounce, that must mean we have a double root right there, right? Everybody see that right here? Instead of crossing through, it just bounced off the x-axis. So that tells us something when we go to write the factors, right? So what would my factors be?
X plus 3, x minus 2 squared, x minus 4.
Right. So make sure that you've got that square on the outside of your x minus 2's factor. Okay? So then they ask for it in factored form. They don't say it goes through any specific point, meaning I don't need to find an a value. So my equation is just all of my factors. So x plus 3 times x minus 2 squared times x minus 4, right? Okay, you guys take a look at number 8. Make sure you pay close attention. See if there's anything weird going on at any of those zeros. Okay. On number 8, where do we have roots? Mm-hmm. Anything weird happen at either one of those? At -4, what happens? A triple root, right. How do we know it's a triple root? Because it has the curve to it, yeah. So if we look right here, we can see that it makes that curve along our x-axis, letting us know we have that triple root. Awesome. So what does that mean our factors look like?
X plus 4
Mm-hmm.
and x minus 1.
Right. Okay. And then they do ask for our equation just in factored form, so that's nice. But they also said it went through this point. So what did we have to do? Find A. Okay. So what did we plug in for our y value? Right. Is equal to our A value, and we replaced all the x's with, right, so we had -1 plus 4 cubed times -1 minus 1, right? Okay, so order of operations tells us to do what's inside the parentheses first, right? So we have our -162a is equal to, in here, -1 plus 4 would be 3. And then in here, we would get -2. All right. So now what would I do next according to order of operations? The exponent, right. So what is 3 cubed? Right, so I have -162a, or 162 equals a times 27 times -2. And now that I've done the exponent, I can multiply, right? So make sure you do the exponent before you multiply the parentheses. All right, and what is 27 times -2? Right? So -54a. And then we had to divide. And we end up getting that our a value is perfect. Makes sense because in our picture, both ends do point up. So our final equation has that a value of 3 followed by our factors, x plus 4 cubed and x minus 1.